This time, let's identify functions using equations. So this is a little bit tricky since we're not given ordered pairs. We don't know exactly what are our x elements and the y elements, but let's learn from the characteristics of equations. Okay, let's begin with example number 1. In example number 1, y is equal to 3. When you say y is equal to 3, that means your only concern is that for for the values of y, so let's say this is your y coordinates, this is your x, the only value that you have here is 3. So this is 3. You can have different x's as long as the y is equal to 3. So I can have here -1, 0, and 5. Or you can use any number here. So which means that for this given equation, we are given with a lot of x's with 1 y. This is many to 1, so this is still a function. Let's have number 2. In number 2, it means that for element in x, we have 5 only. There's a possibility, or you can have multiple numbers of y, so which means that I can have here -7, 0, any number that you have in mind. You can plug it in the y value, so which means that this kind of relation is one to many, and therefore it's not a function. This is not a function, it is just a mere relation. Now for number 3, x plus 2y is equal to 5. The first thing that you're going to ask is that if I will use any values of x, will I have a unique value for y? So let's say, for example, if I use 5 for x plus 2y equal to 5, so 2y is equal to 5 minus 5, 2y is equal to 0, y is equal to 0. So that means if your x is 5, your y is 0. That's the ordered pair. Now, try to use other values of x if you can get a unique y. In this case, this is actually an equation of a line. An equation of a line will give you one-to-one function. Okay, so this is function. Now for number 4, in number 4, all you have to remember is the idea of exponents. The 2 here will tell you that there are 2 possible values of x. So which means that I will have a one value for y for 2 different values of x. So let's have x equal to 0. So when x equal to 0, we will have y equal to 0 minus 2 quantity squared plus 5. So y is equal to 4 plus 5, that is equal to 9. So the ordered pair is when x is 0, y is 9. So that's the first ordered pair. But we can use another value for x that will give you y equal to 9. Let's use x equal to 4. When x is equal to 4, therefore y is equal to 4 minus 2 quantity squared plus 5. Y is equal to 2 squared plus 5, and 2 squared is equal to 4, which will give you 9. So that means when your x is 4, your y is 9. So that means you have 2 x's for 1 y. So this is many to one function. So it's still a function. This time, observe that your y is being squared. This means that when you have the exponent 2, it tells you that you have 2 possible values for y that can result the same value for x, just like what we did earlier. So we can simplify the value in such a way that we're solving for y in terms of x. So that will be x minus 4 minus 3 is equal to y squared. So I'm isolating y squared from any other variable. So that will give you x minus, oh, this is addition. So x minus 1 is equal to y squared. And as you can see, what will you do is that you have to take the square root of both sides. And if you take the square root of both sides, the result is plus and minus the square root of the radicand x minus 1. So observe that for every 1x, there are 2 possible values for y. And what are the 2 possible values for y? Y is equal to x minus 1, and y is equal to negative square root of x minus 1. Which means that if I will use 4 here and 4 here, you will have 2 different y's. Okay? So 1x for 2 different y's. This is one to many, so this is not a function. Okay, now let's have number 6. Number 6 is an inequality. When you say inequality, you have a lot of solutions. When you say y is greater than x That means, example, I have in mind my y is 5. So in this case, when you have 5 as the value of y, so you have a lot of possible value of x that will give you uh, greater than 5 greater than any of these values. Okay, so in this case, since this is an equality, that means you have a lot of values of y when you have one value of x. So let's take, for example, when y is 5, let's erase this one. When y is 5, then therefore you can have, example, 5 greater than or equal to 2, because 5 is equal to 5. We can also have 5 less than or equal to -1. Our target here is to make sure that 5 is always greater than the result on the right hand side, and this is 2. So which means you have multiple values of x that can actually result 1y, but you can also have multiple values of y that can result 1x. So for every inequality, it's always not a function, since both ways you will have lots of x for 1y, or you can have lots of y for 1x. Okay, now let's have number 7. In number 7, you're given an absolute value. Okay, so absolute value, remember, it's talking about the distance, and when you're talking about the distance, this term here should always be positive. So which means that whatever I use for x here, it will result a positive answer. So that means there's a possibility that we can have two different x's but still get the same y. This has the same idea as your number 4. Okay, so you have two possible values of x but you can still get the same y. So in this case, this is already a function because it's many to one, so many possible x's for one y. How about here? It means that there's a possibility that you can have a lot of x. Example, that will be x is equal to y minus 5, which means if I will use x equal to, let's say, y is -1, it will be the same as when I have +1 for your y. So which means 1x and you will have 1x and you will have 1y, -1 and +1 for your y. So it's one to many, so it's not a function. In number 9, you are dealing with a square root. Okay, all the values that you can get here will be positive. Okay, so you're restricted with positive here. You're not allowed to get negative because it will be imaginary. It will actually tell you that for every unique x there will be for every value for x there will be a unique y. Okay, or you can simplify that further as x, you square both sides, and when you square both sides, what happened? X squared is equal to y plus 2, y is equal to x squared minus 2, which means that you have two values of x for one value of y, and this is a function. But even though you're not going to do this, it's still one-to-one function. Okay, because there's a difference when you're squaring both sides and when you're extracting the square root of both sides. Now let's have the last one. In the last one, it's x cubed. When you say x cubed, what is the function of the cube is that when you multiply -1 times -1 times -1, that will give you still -1. 1 times 1 times 1, that will give you equal to 1. So -1 cube and 1 cube will result different values of x. So which means that whatever values of x that you're going to use here, it will give you a unique value. So which means this is still a function because you can have 3 x's for just one y. So just remember that the exponent here will tell you how many possible x's do you have. Okay, so observe this one. It has 2y, so remember you cannot have 1x with 2y's. In this case, you have 3 x's, 3 possible values for x with resulting 1y. So that's okay because it's many to one and it's a function.